All right, so this is a walkthrough of the third packet of notes that I gave you. Probably going to break this up into 2 videos. So this is the first one. So starting off with graphing. So we have our Cartesian coordinate plane. Was made up of a vertical axis, which is your y-axis, horizontal axis, which is your x-axis. Where they intersect is the origin, coordinates of your origin, 0, 0. Everything to the right of your origin will be positive. Everything to the left of your origin is negative. Above your origin, positive. Below your origin, negative. They're split up into 4 quadrants going counterclockwise. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. So to get into quadrant 1 is 2 positive moves. Quadrant 2 would be a negative move, then a positive move. Quadrant 3, 2 negative moves. Quadrant 4, you will go positive and then negative. Your coordinates are made up of what we call ordered pairs. Called ordered pairs because the order matters. It's always your X move first and then your Y move. So you do your horizontal move, then your vertical move. So you can think about you would run and then jump, or maybe you walk to the elevator, go down. Whatever the case, it's your horizontal move, then your vertical move. X comes before Y. So your X move and then your Y move. So just a few points to make sure we're okay with graphing. If I have the point of 2, 5, I will go to my origin. And my X move is the 2, so I'll go to the right 2 and then up 5. Both of them are positive moves, so I'll go to the right 2 and then up 5, and that will be in quadrant 1. If I have -1, -4, I will start at my origin, go to the left 1, down 4, so that puts me in my third quadrant. -4, 3, I will go to the left 4, up 3, that puts me in my second quadrant. And then 2, -1, I'll go to the right 2, down 1. That puts me in my fourth quadrant. The next 2, you wouldn't actually be in a quadrant at all. If I went 3, 0, I would go to the right 3 and then nowhere for Y. So I wouldn't move off of my x-axis, so that point would actually stay on the x-axis. If I went to plot 0, 3, I would go nowhere, or in other words, I wouldn't move to the left or right for the x coordinate because it's 0, then I'll move up 3. So it'd be 0, 3. This actually should be 0, 3, not 3, 0. So it should be 0, 3. So if I wanted to graph this function of y equal to 4 minus x squared, what I would do is create or use the values that he gave me, which is -3 to 3, using the integers of -3 to 3. So -3, -2, -1, 0, 1, 2, and 3. I will plug them in for x to find the corresponding y value. So for each x value, I should get out a y value. So if I plug -3 in for x, that'll be -3 squared, which is 9. That's -3 times -3. So 4 minus 9 is -5. So when x is -3, y is -5. Plug in -2. -2 squared is 4. So it's 4 minus 4, which is 0. So when x is -2, y is 0. Plug in -1. That's -1 squared, which is 1. 4 minus 1 is 3. And then plugging in 0, 4 minus 0 is 4. Also, when you plug in 1, 2, and 3, you'll end up getting the same values they got for -1, -2, and -3. And you see that it'll be 3, 0, -5. When you plot those points, you will get an upside down, or what we call a parabola, upside down parabola. That always is the case when you have your quadratic equation. In other words, your highest exponent when your variable is 2. All right. Function notation. Function notation is just another way of writing an equation or writing a function. You substitute f of x for y. When it comes to function notation, they want to make sure that you understand that y and f of x are interchangeable. They can switch those at any time and expect you to know that they mean the same thing. So y equal to 2x plus 7 is the same thing as f of x equal to 2x plus 7. It's just that the one that uses f of x is actually in function notation. So what you can do with function notation is just allows someone to give you information or give you instructions without writing a whole bunch of words. If they tell you to find f of -3, or even if they didn't have find, and you have f of -3, you want to know what the value would be for f of -3. What this means is that you would just take -3 and plug it into the function where you see x. So you have f of x here, you substitute -3 into that notation. So that means they want you to put -3 into the function where you see x. So that's 2 times -3 plus 7. 2 times -3 is -6. -6 plus 7 is 1. So f of negative 3 is equal to 1. Also, what that means is that, remember, negative 3 was x. And when I plug in negative 3, I got out y. So my ordered pair would be negative 3, 1. All right, a few more examples of using function notation. If I have f of x is equal to 10x minus 3, g of x is equal to 2x squared plus 7, and h of r is equal to r cubed minus 2r squared plus 5. It tells us to find f of 4, g of 0, h of negative 5. So that just means that I would take 4, plug it into my f function, take 0, plug it into the g function, and take negative 5, plug it into the h function. So doing that, looking for f of 4, that's 10 times 4 minus 3 is 40 minus 3, which is 37. So f of 4 is 37. Then plugging in 0, that's 2 times 0 squared plus 7. 0 squared is 0, 2 times 0 is 0, plus 7, which would just be 7. Then plug negative 5 in for r. So it's negative 5 cubed minus 2 times negative 5 squared plus 5. Negative 5 cubed is negative 125. Negative 5 squared is 25. So then we go ahead and multiply 2 times 5, which would be 50. That would be negative 125 minus 50, which is negative 175. Plus 5 would be negative 170. Here we have the vertical line test. It says if a vertical line touches or crosses a graph more than once, then it does not represent a function, or the graph is not a function. So if I have this linear function here, this straight line, no matter where I draw a vertical line, it only touches it once, so that means it is a function. A circle is not a function because the vertical line touches it twice. A parabola, this is the right side up parabola. The one we saw before was upside down parabola. If a vertical line touches it, a vertical line is only going to touch it one time no matter where you draw it, so that means it is a function. Then we have this graph right here. Even though when I draw a vertical line right here, it only touches it once. Once I draw it right here, it touches it 3 times. So that stops it from being a function. So the first one is a function, second one's not, third one is a function, fourth one is not. All right, graphing linear functions. There are 3 methods to graphing your linear functions. These are functions that, notice in the word, there's a key word. The key word in linear function is line. And they will create lines, straight lines. So there's no zigzags, curves, or any type of ends, D's, or anything of that nature. So y equal to 2x plus 1 is an example, simple example of a linear function. We'll create a straight line. So we have 3 methods of creating this straight line. We have x, y chart, which would be the first method. We just finished talking about that. You would choose the x value, plug it in, find the corresponding y value for each. When you graph it, you should get a straight line. Then you have your intercepts and your slope method, which will be in 7.2. So let's revisit the XY chart. If I did y equal to 2x plus 1, wanted to figure out a graph or have a graph that represents that function, I can choose any x values I want. If your instructions tell you to use certain x values, then you do so. But here I chose them, so negative 1, 0, and 1. And you'll see why it doesn't matter in a second. Plug in negative 1, calculate, you actually get negative 1 as well. Plug in 0, when you do your calculation, you get positive 1. Plugging in positive 1, when you get your values, you get positive 3. So when x is negative 1, y is negative 1. When x is 0, y is 1. When x is 1, y is 3. Plot those points, and this is your straight line. And the reason why it doesn't matter what x values you choose, because no matter what values you choose, if you graph it properly and calculate properly, you still create this line. Notice my line goes on to infinity in this direction and goes into infinity in this direction. So if I were to plot a point way over here, it would connect up here, which would still give me a straight line. Same thing as if I chose a smaller value down here, it would create a point down here and still connect and create the straight line. All right, looking at another example, y equal to 3/5 x minus 2. So the best way to choose values for this function is to be strategic in what you choose. Instead of choosing negative 1, 0, or 1, what I would do is choose negative 5, 0, and 5. 0 would be the best choice because 3/5 times 0 is 0, and that cancels out the fact that we have a fraction altogether. But also the other values that we choose, we want to choose values that will cancel out with the fact that we have a fraction. So what we do is choose multiples of the denominator. So that's why I chose negative 5, 0, and 5. If you didn't want to choose any negative values, you could have chose 10, 5, 10, 15, 20, anything that this denominator can divide into evenly. So if I had a 7 down there, I would choose negative 7, 0, and 7. If I had a 9, negative 9, 0, and 9. So whatever your denominator is, you choose multiples of that denominator so that the fraction can cancel out completely. So if I plug in 0, 3 fifths times 0 is 0, 0 minus 2 is just negative 2. If I plug in negative 5, 3 times negative 5 is negative 15 divided by 5. That'll be negative 3 minus 2, which is negative 5. Plugging in positive 5, that's 15 over 5, which is 3. 3 minus 2 is 1. Graph those points, and you'll get this line. The second method is graphing by using your intercepts. Your intercepts, or your x-intercept, is where your graph crosses or intercepts the x-axis. Your y-intercept is where the graph crosses or intercepts the y-axis. So remember when we had values or points that was on the x-axis and points that were on the y-axis. And for your x-axis or your x-intercept, that means your y has to be 0. For your y-intercept, that means your x has to be 0. So that will always be a characteristic of your x-intercept. Y is always 0. And then for your y-intercept, characteristic of all y-intercepts, the x is always 0. So let's do an example. We have 2x plus 3y equals 12. It doesn't matter which intercept you decide to find first. Here I decided to find my x-intercept first. So if I'm looking for my x-intercept, that means y is equal to 0. Plug in 0 for y, that cancels out that term. That'll leave me with just 2x equal to 12. Then divide by 2, x is equal to 6. So when x is equal to 6, that y is going to be 0 for us. Then to find my y-intercept, I let x be equal to 0. Plug in 0 for x, that cancels out that term, leaving me with 3y equal to 12. Divide by 3, y is equal to 4. So when x is 0, y is equal to 4. This method always works best when each coefficient in front of our variables can divide into the constant that's over here. 2 and 3 can divide into 12, and that gives us solid integers. So graph those 2 points, 0, 6, 0, so I'll go to the right 6, nowhere for y. 0, 4, nowhere for x, but up 4. And that is my equation, my function. One more, 5x minus 3y equal to 15. To find my x-intercept, I let y be equal to 0, plug in 0 for y. That leaves me with just 5x equal to 15, divided by 5x equal to 3. To find my y-intercept, let x be equal to 0, plug in 0 for x. That leaves me with negative 3y equal to 15, divided by negative 3. Y is equal to negative 5, so that's 0, negative 5. Graph those 2 points, and this will be my line. All right, last method, slope method, or graphing by using our slopes. Your slope is going to be represented by m, when you can calculate your slope if you have 2 points that lie on the line. If you have any 2 points on your line, you can calculate the slope. The slope is just the incline or the steepness of your line, just like the slope of a mountain or the slope of a roof. So we have y2 minus y1 over x2 minus x1, or y1 minus y2 over x1 minus x2. Either way, it doesn't matter as long as you stay consistent. If you do y2 on top first, then make sure you do x2 on first on bottom. Or if you do y1 first on top, make sure you do x1 first on bottom. Also, the relationship gives us rise over run, which we will use to graph in a second. Once again, the coordinates of x1, y1, x2, y2 comes from any 2 points that are on the line. All right, so to find the slope, let's say we have these 2 points that lie on the line, and we want to find the slope that's represented by this line. What I would do is call one of them point 1, call the other one point 2. It doesn't matter which one you decide to do that with. So negative 3, 1, negative 1 would be x1, y1, negative 2, 4 would be x2, y2. Now I'm going to calculate them both using both ways, y2 being first and then y1 being first, just to show you that either way you'll get the same answer. So y2 is 4, y1 is negative 1. Make sure you don't lose a negative. A lot of times people make that mistake. Then we have x2, which is negative 2. x1 was negative 3. So we have negative 2, negative on top and bottom. That gives you 4 plus 1, negative 2 plus 3. 4 plus 1 is 5 over 1, and that's just 5 as your slope. It is possible to have a fraction as a slope. Leave it as a fraction. Just make sure you simplify it as much as possible. So now if I were to do y1 minus y2 over x1 minus x2, that'll be -1 minus 4. -3 minus -2, that'll be -5 over -1, which will give me a +5 once again. So you just have to be consistent. Y2 first on top, that means x2 first on bottom, or y1 first on top, which means x1 first on bottom. One more example, if I have -3, 4, and 2, -2, I decided to let -3, 4 be x1, y1, -2, excuse me, x2, y2. Plug them in, y2 is -2, y1 is 4, x2 is 2, x1 is -3, so that'll be a -6 over +5. So that would be my slope. Basic behaviors of your slope. If following your graph, following your line, it goes up, that means your slope is positive. Following your graph from left to right, if it goes down, that means your slope is negative. So from left to right, if it goes up, it's positive. From left to right, if it goes down, it's negative. If it's a horizontal line, your slope is 0. If it's a vertical line, your slope is undefined. All right, so graphing using your, well, we're looking at graphing now. So first thing I want to introduce is slope-intercept form. We have y equal to mx plus b. If your equation is solved for y, that means the term or the number that's sitting in front of x is your slope, and the other number is your y-intercept. And remember, if it's your y-intercept, that means the coordinates of your y-intercept would be 0 for x, and then that number. So if we have 2x minus 1, that means the number sitting in front of x is your slope, which is 2. -1 is your y-intercept. If I have -9 over 10 x plus 8, that means -9 over 10, which is attached to x, is your slope. Your y-intercept is 8. All right. Also, we get into that RiseOverRun relationship now. If I want to graph, I need to make sure I analyze that properly. RiseOverRun, your rise move will be up or down. You move it up or down when it comes to rise. Your run is right or left. So what dictates whether you go up or down versus or right or left is if you have a positive number or a negative number. So you have what I call positive move and negative moves. So if your number is positive, you're either going up or right. If your number is negative, you're doing down or left. Okay. So if I have 2/3 x minus 1 equals y, my equation is solved for y, so that means I can take the number that's sitting in front of x as my slope, and the other number is my y-intercept. So I have a +2 over a +3. That means I will go up 2, right 3 for my slope. And then my y-intercept is -1. So that means as a coordinate, it will be 0, -1. Remember, all y-intercepts has x as 0 as a part of your coordinates. So the first thing you would do is graph your y-intercept. Notice I put here graph first. Your y-intercept is 0, -1. So that's right there. And then from your y-intercept, remember 2/3 is a slope that is not a point. So you don't go back to your origin. You're going to generate another point from the y-intercept. From the y-intercept, you go up 2 and then right 3. And that's how you use slopes to graph your line. So you can continue to do that if you want to, and continue to generate points up 2, right 3, up 2, right 3, up 2, right 3, and it will continue to create points on this line. So you graph your y-intercept first, then from your y-intercept, make your slope moves. So if I have -3x plus 5, my slope is -3. The 5 is my y-intercept. Remember, if your equation is solved for y, you can go ahead and do that. If not, then solve it for y. So you can go ahead and extract the information from it. So remember, your slope is represented as a fraction. We're talking about RiseOverRun. So if you don't see anything, they assume you know 1 is there. So we have -3 over a +1. That negative is not given to both top and bottom. Negative over negative is positive. So that -3 is just given to the top number. So that's -3 over +1. That means I will go down 3, right 1. And like I said, your y-intercept will be 0, 5, because 0 is always x when it comes to y-intercept. So you grab your 0, 5, which will be up here. Go nowhere for x, up 5. And from your y-intercept, go down 3, and then right 1. One last thing in this section, and then we'll stop here. On horizontal lines versus vertical lines, notice all of our equations, all of our linear equations up to this point had x and y involved. Let's see if we take it back one. Notice negative 3x, y is equal to negative 3x plus 5. We have an x and y. If all you have is a y, let's say here we have y equal to 3. That means when you go to create or generate your points, y is always 3. X can be anything, but y is always 3. So let's say if we let x be equal to negative 1, 0, and 1. If I were to graph negative 1, 3, 0, 3, and 1, 3, I will get a horizontal line as 3. So no calculation, just observation of what you have. Whenever you have y equal to a number, y is going to always be that number. X can be anything. Now, when I have x equal to a number, it's the other way around. X is going to be equal to that number, or all your x's will be equal to that number. Y can be anything. So here I have x equal to negative 2. Notice x is negative 2 all the way down. I decided to let y be equal to 1, 2, 3. If I were to graph these points, I would get a vertical line at negative 2. So once again, when y is equal to a number and you don't see an x at all, that means y is going to be that number. X can be anything. If I have x equal to a number and I don't see any y, that means x is going to be equal to that number and y can be anything. That will give you a horizontal line, then the other one will give you a vertical line. Let me know if you have any questions.